Okay, good. All right. Well, look, thank you again for the invite and the opportunity to present. I was looking back through the last 2 or 3 years worth of presentations that I've done on this slot, and it was quite profound the rate at which things are evolving. I think it's fair to say that everyone is experiencing the acceleration that this industry is undergoing in terms of technology and transformation right now, underpinned obviously primarily by what's happening in AI. I think what this presentation is about really is the culmination of how Vertiv and its portfolio have evolved into a complete solution offering, which has existed in many respects for a long time, but how pivotal this now becomes in terms of the context of AI, what the UK and Europe are going through now, which is that acceleration of deployment ahead of the initial activity that you quite rightly mentioned, Jordan, and Abby did as well in the US. They've certainly been ahead of the pack in terms of the uptake. But one core for us is a philosophy that explores what's truly possible in today's world. I think in terms of building AI factories for the modern age. So just to kind of set the scene a little bit, AI is predicted to have the steepest adoption curve of any technology in the past 30 years. And whilst AI specifically doesn't feature on this graph because it's being defined, what I found is it's quite an interesting graphic to just give you a visual representation really of the rate of which adoption can really take place across different more recognized technology platforms. The internet being the most aggressive one, reaching but still actually a very limited portion of the population from a US perspective, and we anticipate that AI is going to accelerate even quicker than that. Now, the interesting thing I think to understand around AI and how it's presenting itself as an opportunity from an investment standpoint is the speed element. When we look at AI as a product, you have data, algorithms combined with compute, and then if you couple that with energy in a data center-based environment, that is ultimately what gives you the output. And it's those bottom two channels where we as an industry and the ecosystem of people that will be attending this call are principally focused. But for us at the moment, one of the driving metrics in terms of, let's say, our differentiation and our value proposition towards this new wave of investment is what's called the time to first token. And effectively, that is the speed within which you can start to monetize the investment that's been made on GPUs embedded in IT hardware that are designed to deliver some sort of token-based AI output. And this is really what's kind of, I think, driving the nature of how our industry is evolving at the moment in terms of manufacturers like us and others when they come to look at what the infrastructure requirements are and how they need to fulfill the needs of the market. The CapEx investments associated with the IT hardware are demonstrably higher than what we've seen in prior years with former waves of traditional cloud-based applications and so on and so forth. And therefore, the means by which people are looking to monetize that investment is far greater because they have to see a quicker return on investment. And that is what's driving the time to first token logic, which is in effect from the inception of a project through to the point where I can start to realize revenue from the AI factory that I, Mr. Customer, am planning to build, is one of the key metrics when it comes to development. And that's very much where this presentation is derived from. So obviously with AI, we are in this world of high density compute, right? Typically it's been attached more so to research and development, laboratory-based compute operations, and so on and so forth. But now we see it arriving at scale. And with that, you have a mass uptake, shall we say, and deployment of GPUs. GPUs, by their very nature, are more power intensive and they have more complex cooling requirements. We're seeing in the market that initially, whilst latency wasn't deemed to be a driving factor in terms of the location and the geolocation of AI cloud services, now with the concept of inferencing closer to the user, it's becoming a more prevalent point. The generative AI and HPC labs I talked about, but we still have our environmental and efficiency factors here. Obviously, Abby talking about the nature of what's happening on the grid in terms of a higher portion of renewable sources coming online is a big component. But there's no doubt that as an industry, we face challenges with respect to the perception of data centers. And what that means in the context of AI factories and this future state of compute. And we know as an industry, even from a self-governing perspective, we are very, very good in terms of enforcing the most efficient practice, which by virtue is often the most sustainable one, because it reduces the power consumption associated with our facilities, which is a win-win scenario, but it's still a key aspect. And then there's that speed component. Now, in terms of what our customers face, I mentioned efficiency. That's principally around cooling, and higher density cooling solutions bring with them fantastic opportunities in terms of interfacing with broader public utility infrastructure, the likes of heat recovery for district heating systems and so on and so forth, as well as potentially pairing data centers with agricultural farming within greenhouses or other industrial process-based heating requirements. There's a really, really strong circular economy-based narrative for the deployment of these types of facilities, which is something that consistently needs to be explored and encouraged. We've talked about that in recent sessions or in prior sessions in prior years. The demand aspect is, of course, there. Scalability is very important. What people plan to build today will not define what they need in the future. And then also you have the visibility in terms of, when I talk about the higher level of CapEx that's being expended here, people need to understand the nature of how it's operating, and the criticality of the infrastructure that's supporting the IT hardware at a rack level requires a very, very detailed level of monitoring to ensure that not just performance is optimized, but any potential failure scenarios are understood and anticipated ahead of any critical failures. And also then you have that adaptability component. Now, one of the most challenging things as an infrastructure provider in today's world is that the IT hardware, the GPUs that we are designing infrastructure to accommodate are evolving at such a rate that today's needs will not be the same in 3 years' time. Everyone is experiencing this. There is an excessive amount of evolution driven by the advancements in our technology to be able to support higher density compute in many different capacities. We have obviously the big wide scale market adoption of liquid cooling that's happening now. That's predominantly on a single phase, in a single phase capacity, but two phases is also there. We will likely see stronger uptake in terms of immersion and so on and so forth. But the life cycle of the new generation of IT hardware that's coming through is predicted to be much shorter. The reason being that the technology roadmaps for the likes of NVIDIA and AMD and so on are showing us what's coming in terms of future demand, future capability, and that means higher density from both a power and a cooling perspective. So that future adaptability is a really key component. Now, we talk a lot about about the disruption of high density compute and what it's doing in terms of the data center landscape. But what's important to understand is it's actually only representative of some 25% of rack deployments today. So what we're seeing here is not a complete displacement of former data center type applications. We actually see that some 75% are still 20 kilowatts and below. But what's happening is that there's a very tactical shift towards the adoption of this higher density AI-based IT platforms, because they're providing new services. They're doing new things on top of the traditional cloud-based applications that many companies were running. So that shift is, like I said, it's not displacement, it's net new. So we're getting a richer mix of deployments, but the higher density racks that are coming through have a very specific set of infrastructure requirements, and that presents challenges to the different kind of data center infrastructure types. Enterprise data centers are what we would often refer to as on-prem. To think about installing a couple of high density racks, you could be looking at the initial power consumption of an on-prem data center consumed in the single footprint of one rack. So they have challenges not just around power availability, but then also the readiness of that infrastructure. Is there an existing chilled water circuit that the liquid cooling system can be coupled with? Do you have to look at a dedicated liquid to air based cooling system to navigate that space? as you start to step into co-location and hyperscale, we have data centers that, you know, and of which there's a very large footprint in the UK and Europe that have historically been built on rack densities from sort of 5 to 10 kilowatts. Suddenly introducing HPC or AI-based rack architecture to that space is not something necessarily that the existing infrastructure has the capacity to handle in great volumes, which is why we're sort of seeing this hybrid architecture come through that I'll talk a little bit about on the next slide. And then we have the dedicated AI compute and high density. You know, the projects that we've worked on in years prior to this AI wave were very specialist. We would do works with different universities, R&D facilities, precision engineering firms where they need a lot of HPC compute on-prem. Now what we're seeing is AI as a service and AI cloud-based applications that are being offered by the next generation of neo cloud operators that are coming to market, are building these facilities at scale by themselves because of the investment and the speed within which they need to come to market to capitalize on the GPU sourcing that they've managed to obtain. Now, what this is doing from a rack and a row-based architecture is quite profound. If we look at the kind of classic cloud enterprise space, you know, the rack density, the range of rack densities in this particular slide, it says in the region of 8 to 12 kilowatts on average. And that would mean that the row density, so i.e. the row of racks that you have in a given data center, is on or around 250 kilowatts, very manageable with conventional power distribution and air cooling. As you start to hybridize the cloud and you start to have a mixture of AI-based applications coming into that conventional space, you can have that occasional rack that is some 130 kilowatts, perhaps, if it's on a GB300 platform. So it's a factor of, you know, what is it, 15 times the typical average rack densities in that space, with its very own set of complex infrastructure requirements. And that can start to drive the row-based densities up. But then when you get to the AI factory level, you're looking at actually row densities that are a factor of 5 times higher than what you would see in traditional cloud and enterprise space, which is where you need a very different level of infrastructure requirement, not just in terms of your cooling methodology, but also power distribution. And the density of that IT space is vastly different. It occupies less space. And what you see is within conventional data center design, you now need to apportion a much higher amount to your gray space footprint. So that's the footprint of your heat rejection plant, your power train, the likes of your switchgear, your UPS systems, and so on. There's been a dramatic shift in terms of the balance of those two. I think formerly white space versus gray space would be an 80-20. It's now moving more towards a 60-40, and we see instances where actually it's more like a 40-60 in the sense of the balance of footprint on any one particular site is dramatically in favor of the gray space infrastructure to accommodate the IT equipment because of that densification that's been going on. And so the key trend there is from cloud through to AI is that of a service-driven approach versus an output-driven approach. And output is what the industry now refers to in the context of AI as tokens, usable units of compute. And that is what's driven by the higher density architectures. Now, with higher density comes challenge. Forgive the amount of animations that we have on this slide, but you have wider and heavier racks. You have the compatibility of that IT with cooling, as I've discussed, the cost and associated with it, the complexity of the service, the airflow optimization, the higher amperage power distribution that's required, the profile and loads of those GPUs, the higher capacity power systems that are needed, the potential to utilize and support battery energy storage as part of grid stabilization, grid power constraints, which were obviously discussed on the prior segment, the overall energy and optimization of a system, the compatibility, the emergence of liquid cooling technologies, how the existing heat rejection plant can handle that, the potential for heat reuse, and so on and so forth. The point of this slide is there are a bunch of very, very individual needs that come from this architecture, which is why often we are designing from scratch to accommodate it, especially when it's being built at scale. And this really is where Vertiv comes into its own. And forgive this slide for being a little bit salesy, but as I mentioned at the start, we have now a portfolio within our organization that can address every single one of these challenges. And because the rack level infrastructure is become so critical, and that our equipment now is not defined by a boundary of air within the data center, which is a very safe medium within which to differentiate between not so much white space and gray space, but IT and infrastructure. Now they are very much close coupled, and this is where we really come into our own in terms of being able to work not just with the engineering professionals and the facility management professionals, but actually the IT professionals who are governing, the IT stack and the subsequent infrastructure needs that are required to accommodate it. And so really, as we look towards what the future AI factory looks like, this is where the Vertiv One Core platform comes into its own. And this is a standard blueprint for an AI factory that can be deployed today. So we're working with a number of customers on these at the moment. As I said, the nature of how people are accelerating to get to market in the UK and other regions in Europe is really now quite profound after that initial or the initial investment waves, which very much will continue in the US. It has arrived on the shores of Europe, and there are both sovereign and neo-cloud-based platforms that are looking to capitalize on this business opportunity, and it's about speed as much as anything else. So what you have here is an AI factory, which in effect, this image is a 12.5 megawatt platform, but it's comprised of the complete infrastructure setup that's required to support rack densities of up to 130, 140 kilowatts. So, but the key thing in terms of understanding the speed component is the fact that everything is prefabricated, including the building itself. So the reason that we prefabricate is not just to control quality, it's not just to control the consistency in terms of the design of our architecture and so on, but it's for speed. We, with this platform, are reducing construction times typically by around 50%. Which is really quite profound in a sort of scenario, I think, where we are looking to accelerate and catch up and deploy and establish that AI capability within Europe as quickly as possible. So we've been doing prefabrication as a business for a very long time. Power modules are widely understood as a kind of an industry standard for building more conventional cloud-based data centers. And so we've adopted and densified the powertrain into either skidded or modularized arrangements, but we've expanded that now to also providing skid-based, if I just move on to the next slide, skid-based hydro modules, which is all the pump rooms and chilled water system circuitry, cooling modules and skids, the smart run system, which is actually prefabricated white space architecture, and then even the heat rejection capacity, where we're doing skidded arrangements close coupled to our chillers and trim coolers to be able to capture the buffer vessels that are there to provide the autonomy that's needed in this type of system architecture when you're deploying high density cooling. So it's an amalgamation of decades worth of advancement in our portfolio. But what's really making the use case so strong for this type of technology at the moment is that time to first token and the need to deploy at speed. So as things currently stand, we have a 12.5 megawatt sort of block, as it were, 236 racks with separate primary and secondary fluid networks, fully integrated into the skid and the smart run based architecture. And then you have an air cooling and liquid cooling ratio in the region of 20 to 80%, which is consistent with the SuperBOD platforms from NVIDIA. And I think the key thing to understand with these reference designs is that they are certified by the likes of NVIDIA in terms of compatibility with their system. That reference architecture is the backbone of what they've been designed around, and is forming the majority of deployments that we're seeing coming into the market at this stage. And we maintain the same level of resilience. We're still concurrently maintainable with a distributed level of redundancy and an N+1 configuration, both at the primary and the secondary levels within that space. And then what happens with this is we can scale it. So the reference design that you saw prior was a 12.5 megawatt. We can scale that up to 50, which you can kind of see from the imagery now is in effect a 4x scaling of the prior slide. And this is where we can then start to, to work with customers to understand what is the requirement that they need to deploy in the next, 9 to 12 months. But then what does the future requirement look like in terms of the power availability that they have on that site? And that scalable approach means that you can control not just your CapEx expenditure and phase that, but also you can have in mind that the future state of these AI factories can be adapted to the roadmap and evolving requirements of the chipsets. I'm sure over the coming days you will hear people talking about rack densities that are 600 kilowatts plus, maybe even pushing a megawatt. That will happen, and it will happen in the not too distant future. And this platform provides the backbone of evolution to cater for those demands as they are needed. The latest announcement that we did was for the gigawatt scale reference architecture for the Omniverse DXS blueprint, which was announced at NVIDIA at GTC. And this again is driven by the scale at which they are looking to deploy, not NVIDIA specifically, but the people that are buying that platform, the likes of the neo clouds, the likes of the major AI houses, and so on and so forth. They need to build quickly. They need to build at scale. That scale, the boundaries of what scale looks like are being tested. And this is very much kind of where we are today, and we're very excited to see it come to market. So just to wrap up, I think why it makes so much sense, the single source pre-sales element. There's a dramatic amount of reduction in complexity through embracing this type of project philosophy and from an execution standpoint. The leading engagement that we can offer as an AI technology partner within this space, not just with NVIDIA, but others, we're very closely coupled with them when it comes to, sharing our technology roadmaps to ensure the future compatibility of our infrastructure with the IT hardware. But ultimately, that innovation in terms of approach is very key. The time to first token reduction, the maximization of that data center footprint using a single source supplier that knows the true boundaries and limitations of all aspects of the infrastructure and their intercompatibility. And then the management piece, the service component. We're talking about AI factories now that are going to have, the same, if not more extreme SLAs that we've typically been used to within the data center environment. The criticality of these platforms doesn't change. And with that comes, an organization like ours that has a very, very strong service footprint, direct service footprint, and a long history of managing and supporting customers within the market in that space. So I will close off there. I think that pretty much brings me up on time with a little bit of time for questions. So over to you, Jordan.
Amazing. Thank you, Alex. There are no questions from the audience yet. So if anyone in the audience does have any questions, then leave that in the Q&A box while we have Alex. This is your opportunity to ask any questions. And also, I just want to say real quick, thank you. I know how important it is to scale up AI as quickly as possible because AI is waiting for no one. And I think it's especially important in the UK. Because we want to be able to compete with the rest of the world. And unfortunately, as I said at the beginning, you know how hard it is to build anything in the UK. So
there's a lot of headwinds, right? And I think that we can see without putting too much of a political tone on it, we can see that a lot of those headwinds are being worked. But I think that what the philosophy offers, be it Vertiv or otherwise, is to recover that time as much as anything else, right? And like you say, there's a race happening on a global stage. From with each nation looking to invest and establish its own sovereign platform, and then there will be broader cloud-based services that exist on top of that. But the need to get ahead is really critical, and that's kind of what it offers, I think, in terms of a philosophy.
And I think you nailed that 100% in terms of what you said there, in terms of, you want to claw back that time. Planning's going to take a while. You don't want construction to take even longer. The construction industry at the moment is under real pain when it comes to skill shortage. So again, anything that makes it easier and more deployable makes life for everyone in this industry much easier. And as I say that, we had a comment from John's side. All the tech is designed to keep the CPU and GPU cooled. What technology do you use to Halo manage power? Is it monitoring capability autonomously, adjusting depending on workloads?
Yeah, in short, we could we could take a couple of hours alone just to talk about that, and please, John, feel free to reach out for a bit more of a dedicated session. But yeah, in effect, you have to have a very close coupled, level of monitoring between the nature of how the IT load is likely to fluctuate, and then what the subsequent downstream impact is on your powertrain in order to manage that. So with the Trinergy platform that we've got on UPSs, for example, we've done a lot of advancements and a huge amount of testing on stressing the capabilities for it to deal with volatile load profiles. And we've had to make some slight updates in terms of configurations to cater for that. But it's very much within the bounds of the equipment. So I'm not an electrical engineer. I come from the cooling side of the business, so I probably won't do that answer the most amount of justice. But John, feel free to reach out, and we can happily I can put you in touch with one of our application engineers for a more dedicated discussion.
Yeah, John said he'd love to catch up. So seek Alex out and give him a message, and then I'm sure
if you can't find me, if you can't find my email on this, just grab me on LinkedIn. But,
yeah, excellent. Actually, to your point, Vertiv is known for power solutions, so I would be very surprised if power wasn't at the top of the list along with cooling when it came to building the solution.
Absolutely.
Well, thank you very much, Alex. That's all the questions we have now. If anyone, oh no, but just as I say that, we have another question. How does your technology manage leak in the TCS side?
So you have different levels of obviously leak detection that you can put in, and then you can have a negative pressure-based system as well to avoid, in the event that you start to lose pressure within the system, you can induce a negative pressure that then stops the secondary fluid that we're actually leaking. There's different ways in which we can do it. Again, I can reach out for a dedicated discussion on that topic.
Amazing. Thank you, Alex.